Okay, hi class. Now we go to chapter 3, electromagnetism. Okay, so as I mentioned in our meeting just now, we have 4 parts in this chapter. So we are going to first part, what we call electromagnet. Electromagnet is a temporary magnet when current flow through conductor. Okay, so when current flow through conductor, okay, so when current flow through conductor, let's say this is copper wire, and when there is current flow through, you will have this what you call temporary magnet. Temporary magnet means that once you, let's say this is what you are going to connect to battery, let's say. So when you switch on the switch, when you switch it on, the current will flow through, and then you can see there is actually magnet. Once you switch it off, let's say you switch it off, so the magnetism will actually disappear. So this is what we call temporary magnet when current flow through conductor. Okay, so this in electromagnet initially come from a scientist named Oersted. Okay, so Oersted, so people know that actually when there's current flow, there is a magnet that we call electromagnet. Why is it we didn't really realize in our daily use wire, like our electric wire, our computer charger, our phone charger? We can actually see the effect at the adapter itself. You try to put paper clip there, and then you can see actually the paper clip will be attracted to the adapter. But it is not so obvious because the current that come to our house is actually 240 volt, right? So 240 volt, but the current is actually small. Okay, this is voltage, current is actually small. Why? If you still remember previous lesson, chapter 2, we said that power equal to IV, right? So when the voltage is very high, the current should be very small. Why is it we want to maintain current very small? That is because of bubble milk tea of Lo Bun Jun. You still remember that he said that current killed? Yes, current killed because normally human, we can feel 20 milliampere actually. It's quite an experience of electrocute already, 20 milliampere. But more than that, it definitely kill lah. So what is the killing current? Okay, you can search and then you tell me the answer later on next week when we meet again. Okay, so what is the killing current, the number? Okay, so what I can say here is that the current is very small because we set our voltage very high, and then the frequency that we use, this is alternating current. Now we get alternating current from Sarawak Energy, so the alternating current is actually in very small frequency. So if the frequency is very huge, we can actually see the magnet thingy very obviously. Okay, so first thing you have to know is what is electromagnet, and then how are we going to determine the magnetic field that produced. Okay, so this is wire, current flowing out, we use right hand grip. You actually learn this in your form 3. So right hand, your thumb will always point towards the direction of current. Okay, and then you see your finger will actually showing, so this is wire, your finger will showing the direction of the magnetic field. So you can see that it is actually like this. Okay, it is actually like this. So if I put a compass here, I can see that the needle will turn that side, inside, and then I see a compass here, it will point like this. See a compass here, it will point like this. So this is direction of electromagnet. We use right hand grip rules. Okay, so of course this is only one wire. Okay, so in exam they will give you something like this, pangka or dot. Okay, if it is a cross, means that the current actually going in. Okay, imagine you have a wire here, you see wire, this is what? This is wire. Okay, so current going in because the symbol cross actually means that the current going in. So when current going in, so I use my right hand grip. Okay, so you can see that my finger actually in this direction. Is that okay? You must be able to draw this lah. that is normally asked in exam, can be structure, can be section B. Okay, and then dot means that the current come out, right? So dot means that the current come out. So when the current come out, you can see that it is anti-clockwise. Okay, so the magnetic field line will be turning anti-clockwise. This one is clockwise. Okay, anti-clockwise and clockwise. So if you put two wires together, one cross, one dot, means that the current actually come out like that and then go in and come out, go in. You can imagine, right? So you can see that you actually get a very strong attraction force here, very strong attraction force over here, because here you see same direction, right? So you will get this is what we call magnetic crane, that you can pick up the rubbish of scrap car or scrap iron, steel, and so on. Okay, so what if I use cross and cross? You see that cross and cross will be like this, right? So you will actually cancel out each other. So here this area become weaker. So we don't want this to happen. That's why we must always ensure that the current is actually one in and one out. It's just like the magnet that we use. You know, Tom and Jerry, the mouse always use this magnet to attract something, right? So you see Tom and Jerry, they always use South Pole and North Pole all together. You never see a magnet that look like this, South Pole and South Pole, right? Because South Pole and South Pole, somehow it will cancel out each other like this case above. That's why we always make sure that it is different polarity or different direction in the current. Okay, so this is what you have to know. You must be able to draw this line. Okay, remember cross means that going in, dots means that coming out. Okay, and then the number of line determines the strength of the magnetic field. Okay, what if, of course, one wire is not so effective. What if we have a coil of wire? We call it solenoid. Okay, so this is solenoid. Okay, so let's say I have current here. So solenoid also we use right hand grip. Okay, how to determine the direction? Okay, you have to use the right hand grip also, and then remember your thumb always point toward North Pole. You see that current flow like this, coming out, right? Like this. So I will use my finger, I point like this. Okay, so let's say this is a coil, then it is like this. So my thumb will always point towards North Pole. So this is South Pole. Okay, or the symbol of North Pole is actually look like this. Okay, South Pole is actually look like this. Okay, so North Pole always come out, right? If you still remember, South Pole always go in. You always go in as right and come out from north. This is the magnetic field line that you're supposed to draw. No cross sectional, no intersect line, and then the density of line represent the strength of the magnetic field. Okay, so what is the factor affecting electromagnet? What is the factor affecting electromagnet? Okay, of course the first one will be the current. Okay, the first one will be the current. If the number of current increase, okay, the electromagnet will be very strong. And also another thing is that we use soft iron core. Okay, why is it we must use soft iron core? There is a question always asked in exam. Why we need to use soft iron core? First is that it concentrate all the field line together. So if inside I put soft iron, okay, and then it will make sure that this soft iron will actually concentrate all the line together. So it will concentrate all the electromagnetic field line. And another thing is that it will actually amplify or magnify, and also it can be magnetized and demagnetized easily. It can be magnetized and demagnetized easily. It concentrates the fine line and slightly amplify the electromagnet. Okay, so electromagnet, first thing you have to know what is the definition. It is temporary magnet when current flow through the conductor. You must be able to draw the magnetic field line. And then here, third thing you have to know what is the factor affecting electromagnetic strength, current, and then we use soft iron core. And then a number of turns. Yes, number of turns. If you have more turns, of course you have more, the magnetic field line will be more. Okay, then last one is the application. You can actually go through the knots here. Okay, you can actually go through the knots. We have electromagnet is very famous question. Almost every year SPM will ask about electromagnet. There's no exception. I don't know why. Okay, you see that we have this electromagnetic lifting machine. Okay, so once you switch on, it attract all the steel. Once you switch off, and then the whole thing will drop. Okay, so electric bell. This one, the bell. And then we have a relay. All this asked already in SPM. Yes, our earpiece, speaker, microphone, circuit breaker, all these things actually are the example of application of electromagnet. Okay, so after electromagnet, we will go to the second part. Okay, so you have to remember electromagnet come very far earlier. Okay, it actually started from oyster. After that will be induced EMF. Induced EMF we will talk about Friday. Okay, so I will continue with second video later on. Okay.